Still on indicial or exponential equations, we now consider solving indicial equations by substitution. Okay, in the first video under indicial equations, we considered solving indicial equations by comparing by equating indices. In the last video, we looked at solving indicial equations by same base conversion. That is, if you don't have the same base initially, you can convert to the same base and then solve, right? Basically about the same. Then here things get a bit more tricky, a bit trickier that is. Here we're looking at how to solve initial equations by substitution because we won't be able to just compare indices or just do same conversion. It may involve all of that, but we now need to go further and substitute. So let's see what that looks like. So solving initial equations by substitution, in this case, we need to do something like, substitute. The method is like saying, let a raised power x be equal to t. A is the base, x is the exponent. Of course, we know that an initial equation in that is that equation in which the unknown is at the exponent level, is at the power level. That's why it is an initial equation. So in some cases, we may need to substitute the whole chunk of the base raised power, the exponent, we equate it to t or p or anything you choose to equate it with. It doesn't have to be t, but this is just a generalized way to represent it. So the learning outcome is that after this lesson, you should be able to recognize exponential equations reducible to polynomial form, then use substitution a raised power x equals t, or if you like p or q or anything, then solve the resulting quadratic or polynomial. Then after doing that, since you didn't start with t, then you can now, once you get the t's, you can now substitute back to find the x which you are looking for originally. So don't ever forget that you did not start with t, you started with x, and you must get us the answers back in x. So then, of course, you want to reject impossible solutions as you're going to see. So the question is, why does this work though? Consider this equation that 2 raised power 2x minus 5 dots. Now, this 5 dots means 5 times 2 raised power x. So when you see this dot in this case, and it is different from when I said 1 dot, that's number 1, and I say 1 dot. No, so if you see it in between an expression like this, it's multiplication, not decimal. Okay, not decimal. Make sure you get that. So you have 2 raised power 2x minus 5 dots 2x plus 6. Maybe another way to make it nice is to say 5 bracket 2 raised power x. But once you see this dot, we know it's multiplication. So consider an equation like 2 raised power 2x minus 5 dot 2x, 2 raised power x plus 6 equals 0. So you can notice that, first of all, 2 raised power 2x is the same thing as 2 raised power x raised power 2. Going by the power law, the exponent law, that is the power of a power. So if you have the power of a power, just multiply the powers, right? So you can do this 2 raised power x as 2. Then we have 2 raised power x here. Then, because if you look at this now, you cannot just equate. There's no power to equate per se because the expression is totally different. So, but we can see a pattern that, oh, there's 2x here. We can also take 2x out of this place. So we can, then this suggests that letting 2 raised power x to be t. Here, we said a raised power x should be t. So here, a is the base. So 2 is the base here. So 2 raised power x equals t. So if we have that, then it means that 2 raised power 2x will be t squared. And then we now have minus 5t plus 6 equals 0. And that looks like something amenable to solution based on our knowledge of polynomial equations. So the equation then becomes a quadratic in terms of t, which we can solve. And then by the time we get t, we can take it back to where we're bringing it from. So that's what we are here for. So worked examples, we have a number of those. Imagine, can I show everything at once? So I think it's quite some steps. Okay, let me just go step by step. So I'll just read out this, then the next one I'll solve it on the worksheet uh, like that. So you have 2 raised power 2x minus 5 dot 2 raised power x plus 6 equals 0. So first step is substitute, right? So we can already see 2 raised power x can be t, then 2 raised power 2x is the same thing as t squared because 2 raised power 2x is 2 raised power x raised power 2. So since this is t already, then it means this whole expression is t squared. Then if you substitute it back, you have t squared minus 5t plus 6. Okay, so you have t squared minus 5t plus 6. So that's not a quadratic expression that we can easily solve using any method. We can factorize, we can use the formula method, but we can easily factorize. So here you need two numbers you multiply to get 6. And then if you add the two numbers, you get minus 5. So because of the minus here, it means that the two numbers must be negative. So that will be minus 2 and minus 3. So if you have t squared minus 2t minus 3t, that will give you minus 5t. Then minus 2 times minus 3, that will give you 6. By the time you factorize, we have t minus 2 into t minus 3 equals 0. Therefore, t is equal to 2 or t is equal to 3. Now, don't forget, you didn't start with 2 or with 2 t. So you have to now take it back to the x you started with. So what do? You substitute back t is 2 or t is 3. So if you now say that, oh, recall that t is 2 raised power x, right? So we can then say 2 raised power x equals 2 when t is 2. So you have 2 raised power x equals 2, and then you have 2 raised power x equals 3. For the first case, for 2 raised power x equals 2, that's 2 raised power x equals 2. 2 itself can be written as 2 raised power 1. So because they have the same base now, you can say x is equal to 1 easily. So x is 1, clear. Then case 2 now, you have 2 raised power x equals 3. Well, try hard as you may, yeah, you can't get 3 to be based. Well, you can do some things, but that'll be it's not necessary. So once the bases cannot match, as you're going to see, I think in the next two videos or so, we'll see how to solve initial equations by taking logarithm of the base. All right. So here now, you can take, so one way to get x out of here is to take log 3 to base 2. So because 3 is base, 2 is base here, so we'll take the logarithm of 3 to base 2. And of course, you can use decimals for that, right? Because logarithm of 3 to base 2 is the same thing as logarithm of 3 all over logarithm of 2. So this is what we mean by this. So if I go to decimals, okay, or if you can punch your calculator, right? So let's see. I go for this now. Then I try to do log 3 base 2 base 2. Yeah, so you see that log 3 base 2, that's 1.585. Okay, we have 1.5, that's the 1.585 right here. That's what we're getting from this. Okay, log 3 base 2. So how did I punch this again? So you can even do the base first. So just do shift underscore, that's 2, then 3. So you get 1.585 like this. So that's how this happened. So now we have got the two results. So final answer means x is equal to 1 or x is equal to log 3 to base 2. That's example 1. Example 2 now. Okay. Example 2. Okay, I promised to solve that, right? So we have 3 raised to power 2x minus. Okay, I guess I want to take a shot of that so I don't have to keep going back and forth. Hope this is possible though. Yeah, I think it should be rectangle. So I just want to crop this out. This is what we need now. Okay, so I can save that on the desktop as problem 1, if you like. Hope this is not too much of a. I think the process is too much. So can I just transfer it? Can I just copy? Okay, I can copy this and close. Then I come back here. Can I just paste Control V? Oh wow, it works. Lovely. Yeah. Huh. So I think this is an easier way to go. So we need to solve this now, right? So can I still drag it? Okay, it's not responding, but it's okay. Now we need to solve for x here. So now I have 3 raised to power 2x minus 4 times 4.3x is like 4 times 3 raised to power x minus 5 equals 0. So we can say, uh, of course, this is 3 raised to power x. And this 3 raised to power 2x means you have 3 raised to power x raised to power 2 minus 4 into 3 raised to power x minus 5 equals 0. So we can then say, we switch gear here. So we can say let 3 raised to power x be equal to p. It doesn't have to be t, it can be anything. Let it be equal to p. Now that it is equal to p, so it means that from here now we have p squared minus 4p minus 5 equals 0. So we have that. Now that that transformation is complete, we can then go back. So this is a quadratic equation in terms of p. And to do this now, we have minus 5 here, of course, and we have minus 4 here. So we need two numbers When we multiply those two numbers, we get minus 5. And when we add those two numbers, we get minus 4. And it looks to me like those two numbers should be, because this is negative, because this sum is negative, it means that the two numbers can be negative and positive, right? So we have minus 5 and we have, there should be factors of 5, by the way. So we can have 5 and 1. So minus 5 and plus 1 should do the job, because minus 5 plus 1 is minus 4. So they will do the job for sure. So we can then come here and say this is p squared minus 5p plus p minus 5 equals 0. Or if you like, p minus 5p plus p minus 5p, that still works. So now we can factorize. We have p squared minus 5p plus p minus 5 equals 0, so that p here is into p minus 5 plus nothing is 1 is common here, into p minus 5 equals 0. So we have p minus 5 equals p plus 1. Okay, p minus 5 is common, into p plus 1, like this. So, and that is equal to 0. That means that p minus 5 equals 0, or p plus 1 equals 0. So that means that p is equal to 5, or p is equal to minus 1. Now, uh, but don't forget that you didn't start with p, so you cannot end with p. We started with x. So, but where did that change happen? 3x equals p. So you then recall that 3 raised to power x is equal to p. So you can now say for p equals minus 1, it means you have p, it means you have 3 raised to power x equals minus 1. No matter what you do, this is not going to work, okay? So we have to reject this solution. So because you can, number one, you cannot write minus 1 as 3 raised power something. Then number two, if you even take the log, it won't work. So we reject these solutions. So that solution is discarded. Then for the other one now, p is equal to 5, I believe. Yeah, p equals 5. So we can then have 3 raised to power x equals 5. So though we cannot write 5 as log of something, right? As we cannot write 5 as 3 raised to power something, but we can take the logarithm at least. So, and since 3 is the base now, x here can be written as log 5 base 3. And log 5 base 3 will be approximately, I think we did something like that. Log 5 base 3, we go to decimals or punch your calculator. Log 5 base 3 base 3. So we get 1.4649 or 1.465, anyhow you like it, 1.465. So this is approximately 1.465. So at the end of the day, we have got our answer. So x is approximately 1.465, but we end up rejecting minus 1. So if you go to the to the note now, that's exactly what you get. So I mean, all the process, you have you select 3 raised by x with t, and if you do that here, we have 3 raised by 2x into all the things I did. So t squared minus 40 minus 5, then find two numbers that multiply. I mean, that I explained all of that. So we have 5 and minus 1. Okay. Uh, then we now check. We ended up getting 5 and minus 1. Check the validity. 3 raised power x is, 3 raised power x is always greater than 0 for all real x. That is why 3 raised power x can never be equal to minus 1, because exponent like this is always positive. 3 raised power x is definitely positive, so it can't be minus 1. So this one has no solution. So we reject t equals minus 1 like I did. Then solve for the valid case. 3 raised power x is 5. If you take logarithm base 3, you get 1.465. And the final answer is that x is log 5 base 3, like what we got there. Okay, so this one I can also explain. Uh, uh, you know, substitution with shifts now. Now, so we have a possibility of having a shift here. So imagine you have 2 raised power x plus 1 equals 2 raised power 2x. Now, if you rewrite using exponents, you discover that this 2 raised power x plus 1 is the same thing as 2 raised power x times 2 raised power 1. Okay? Because from the law of indices, if you're multiplying 2 raised power x and 2 raised power 1, it means you have 2 raised power, just add the powers. That's 2 raised power x plus 1. So you see now that 2 raised power x plus 1 equals 2 times 2x. So that means both sides are the same. And since both sides are the same, if you simplify, these two sides are identical because 2 raised power x plus 1 is exactly the same thing as 2 times 2x. So now it means both sides are identical. Therefore, the equation is true for all real values of x. So if you have the two sides exactly the same, then it means that the equation is true for all x. So for any x you have, yeah, these expressions are going to be true. So if you have x to be 100, x will be 100 here. So if you have x to be 1 billion, if you have x to be anything minus 7, it will be minus 7. So the final answer is that all real numbers satisfy this particular expression. So that is when you have substitution with shifts. So here, what you've seen so far, if you want to talk about the systematic method summary, step one is ensure all terms have the same base. All right, so that's step one. Step two, let a raised power x be equal to t or p or q, anything you choose. Then step three, rewrite powers such as a raised power 2x equals a raised power x squared equals t squared. If you even have like a raised power 3x, that means a raised power x raised power 3. That would mean you have t raised power 3, depending on the expression you have. Then step 4, solve the resulting polynomial. Step 5, substitute back that a raised power x is t. And then step 6, reject invalid solutions since a raised power x is greater than 0. So if you get anything negative, then it won't work at all. So I think I should take one or two questions here before we round off. So from the practice problems, let's see the first 10. So solve each equation by letting a raised power x be equal to t and reducing to a polynomial. So which one should I take now? Which one should I take? Which one should I take? So in this case, you don't have to worry. You don't have to bother about taking it, reducing it to the same base, you know. As far as the base is consistent, I'm reducing to prime number base. Yeah, that's what I meant to say. Which one should I go for? Let me take 5. Should I take 5? Yeah, let me take 5. So again, let me do the normal snipping thing. Oh, okay. How did you get here? All right. Let me take the normal snipping thing I did the other time. Oh, I've gone too far. Okay. Yeah, 1 to 10 is what we're looking at. So I'm answering question 5, like I said. So let me snip like before, since I can just copy and paste. So I have this rectangle question, I'm taking question 5. Okay, 4 is power 2x, blah, blah, blah. So now that we have this, I learned that I can just can copy this, take it to the worksheet. Okay, and then I can paste it here. Control. Oh, okay. Just paste. Good. So I have this now to solve. So first of all, I know this is I see 4 raised power x here. So I can say this is 4 raised power x raised power 2 minus 5 into 4 raised power x plus 4 equals 0. Okay. So I then say let 4 raised power x be equal to q. It can be anything, so don't be fixated on t. So this will now be q squared. So this now is q squared minus 5q plus 4 equals 0. So I need two numbers which were multiplied. I get, if I multiply two numbers multiplied, I get positive 4. Okay, and two numbers when added, I get negative 5, and they have to be factors of 4. So obviously they have to be 4 times 1, 4. But then because this is negative now, it means this has to be minus 4, and this has to be minus 1. Minus 4 times minus 1 is 4. Minus 4 minus 1 is minus 5. So I got my factors, my numbers already. So I can go back and say this is q squared minus q minus 4q. Minus q minus 4q is minus 5q, by the way. Then plus that 4. Okay, plus 4 equals 0. So I can factorize it. I can group. I have q squared minus q minus 4q minus q. Now, this plus becomes minus because I have a minus outside there. Once you introduce the bracket, this one changes to minus. So that if I expand, I can get minus 4q plus 4 plus q back. Oh, this should be plus 4 actually, because this 4 here. So, but this plus changes to minus because there's minus outside the bracket, and this is equal to 0. So next, I can factorize. So q is common into q minus 1 minus 4 into q minus 1, and that is equal to 0. Okay? So I then have q minus 1 into q minus 4 equals 0. So that means if you equate to 0, okay, q minus 1 equals 0 or q minus 4 equals 0. Because if a product is equal to 0, it means at least one of them is 0, or both of them are 0. So Q equals 1 here, or Q equals 4, which is cool. But never forget that you did not start with this. What do? You have to recall that 4 raised by x is Q. So recall 4 raised by x equals Q. So what does that mean? It simply tells us that at Q equals 1, 4 raised by x is equal to 1, and that means 4 raised by x, 1 can be written as 4 raised by 0, because anything raised by 0 is 1. So we can then equate the powers. So this simply implies that x is equal to 0. So we get x there. Then, on the other hand, we say at Q equals 4, we have 4 raised by x equals 4, right? Because the two Q's are 1 and 4. So 4x is 4, and then it means 4 raised by x is equal to 4 raised by 1. So that implies that because the bases are the same, x is equal to 1. So what we conclude that x is equal to 0 or x is equal to 1. These are the two values of x. Well, I always also taught you to check. So you may want to check. So to check that, what's the original problem? It's okay, let's even check it because we got x to be 0 or 1, right? So we can check. So when x is 0, we have 4 raised power 2 into 0 minus 5 into 4 raised power 0 plus 4. So that means we have 4 raised power, this is 4 raised power 0 minus 5 into 4 raised power 0 plus 4. And that is equal to 4 raised power 0 is 1 minus 5 plus 4. Everything is 0 because 1 minus 5 is minus 4. Minus 4 plus 4 is 0. So for 0, we are good. So what about the other one for x equals 1? So we have 4 raised power 2 multiplied by 1 minus 5 into 4 raised power 1 plus 4. So that means 4 raised power 2 minus 5 into 4 plus 6 plus 4. So that means we have 16 minus 20 plus 4, which is also 0. So we are good to go like that. Okay. So I think it's not necessary I do another problem because it's the same process. Okay. So just do, so this is now 11 to 20. So same procedure, anyone you choose, exactly the same procedure. This 5 is tempting though. This question 11 is tempting. I think I should do it. I think I want to do that. It looks a bit different from everything we've been doing. That's why I'd like to just check that out. So we have question 11, right? Or should I, yeah, question 11 or 12, which one should I settle for? Okay, let me go for 11. Anyone is fine. So again, I snip that. Then thankfully I can copy. Where's that copy? Yeah, I can copy and then come back to this page. All right, and paste. So I just come here. I can paste. Okay, that's not working. How did I do it the other time? Paste. Okay, nice. So I can paste like this. So again, I take it up and uh I have so for this now, things are a bit trickier here, but okay, this is how we can go. We have 2 raised by 2x times 1 plus 1. That will be 2 times 2x times 2 raised by 1. At least that's sure, because these two together gives this. Then minus 5 times 2 raised by 2x, then times 5 times 5 times 5 uh 5.2x dot 2 raised power 1. Yeah, these two will give me this. Okay, and this is plus 4 equals 0. So this is a bit trickier, but no worries. Now further, we can say that this is so to make things tidy, so this is more like 2 now, this 2 here into this 2 raised power 2x is now 2 raised power x raised power 2, because this 2x all squared is this expression now, minus 5 times 2 into 5 times 2 is 10. We already know that's 10 into 2 raised power x. Okay, this 2 raised power x now plus 4 equals 0. So with this, we've tidied it up a little bit. So at this point, we can then say let anything you like. We can say let 2 raised power x be equal to m. 2 raised power x is equal to m. Okay, so we then have that this is 2m squared, because this is m squared, minus 10m plus 4 equals 0. Okay, now what do we have to do here? Because this x squared, the coefficient is not m squared, the coefficient is not 1, so we have to factor that in. So we have 2 times this. So we need two numbers we multiply to get 2 times 4, which is 8. We need two numbers to multiply to get this 8. And then we need two numbers to add to get minus 10. Get this minus 10 right here. And those two numbers have to be factors of 8. And it looks like, so for them to be factors of 8, what are we saying here? Okay, this is 2 times 4, right? 2 times 4 is 8. So we need two numbers. When we multiply, we get 8. But when we add, we get minus 10. So, what should that be now? Okay, maybe before I even go all that way, we can, so it looks like we may not be able to factorize, but I mean, we can still divide through by 2 here. Or maybe I should have even divided. Okay, yeah, it's not obvious from the beginning. I hope everything is fine though. Yeah, 2x plus 1 minus 5. Yeah, I think we're good. Yeah. So we can divide through by 2. So divide through by 2, divide through by 2. Divide through by 2. So it means we have m squared minus 5m plus 2 equals 0. Okay, so from this now, it looks like we can't factorize directly, but we can surely get m to be minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, this one is a bit complicated, but it's okay. So we have m is minus, so a here is 1, b is minus 5, and c is equal to 2. Okay, so that's minus 5 plus square root of minus 5 squared minus 4 into 1 into 2 all over 2 times 1. Okay, so we have m to be equal to 5 plus or minus square root of 25 minus 8 all over 2. Okay, so m now is equal to 5 plus or minus square root of 25 minus 8. That's root 17, I believe. Yeah, all over 2. So that means we have m is equal to 5 plus or minus. So we need to get 17, right? We need to really get, okay, we can split it up. So we have m1 to be 5 minus root 17 all over 2. Then we have m2 to be 5 plus root 17 all over 2. Okay, so I mean, clearly m1, m1, we have to reject this because this is undefined. So we have to reject. So reject this. Since root minus 17 is undefined, we have to reject that. So we have one solution to work with now. M2 is this. So that means we can face this now, that m is equal to 5 plus root 17. Okay, I can use Desmos to get root 17, right? Square root of 17. Okay, I guess I can open another one. SQRT 17. So that's 4.1231. Okay, 4.1231. So that's 4.1231. 4.1231 divided by 2. Okay, so m now is 9.1231 all over 2. So that means that m is equal to 2 in 9, that's 4, remainder 1. 9.1231 divided by 2. I'll just quickly go to a Desmos. 9.1231. So I have 9.1231 divided by 2. So that gives me 4.5616. 4.5616. So this is 4.5616. 4.5616. So we have this, but don't forget that's not we're not always with m, right? M came in at this point. So then recall, recall 2 raised power x is equal to m. That means we have, so the only case we have left is this. So we have 2 raised power x is equal to 4.5616 approximately. So it means that x itself is log 4.5616 base 2. So that will give us something. So x is approximately log 4.5616 base 2. Log 4.5616 base 2. Okay, we can take this one back. Okay, log 4.5616. First of all, base 2, then 4.5616. That's 2.189 or 2.19 roughly, right? 2.19. Okay, so this is approximately 2.19. That is what x is in that context. Okay. So I think we are good to go with this now. So that's us taking care of question 11 right there. So with this, we come to the end of this interesting video about solving indicial equations by substitution, because we can't merely compare or equate coefficients. Let me know how helpful this is for you, and if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, I thank you very much for doing that. If you haven't subscribed, why have you not? Go ahead and subscribe right now and hit the notification bell so you can always get alerted each time a new video is released. All right. Having done that, you can also become a member of this channel by clicking on join, and that gives you some special privileges, like you get to see some videos first, or you are the only one to see certain videos as members, or we can also hang out to discuss whatever interests you in this channel, be it mathematics, data science, scholarships, anything at all that is of interest to you. We can hang out and discuss about them. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.